Narik is here. Today I'm going to solve the third exercise from the second session 2015 chemistry, electrochemistry, galvanic cell. A galvanic cell constructed by a grade 9 student is represented in the adjacent figure. So we have Cu strip in solution containing Cu2 plus, Zn strip immersed in solution containing Zn2 plus. The overall reaction of the adjacent functioning galvanic cell is represented by the equation given below. Zn plus Cu2 plus, it gives you Zn2 plus Cu. Show using oxidation numbers that the overall reaction given above is an oxidation reduction reaction. So you need to check the number of, so the reaction is Zn plus Cu2 plus, it gives you Zn2 plus Cu. So Zn is 0, Cu2 plus is plus 2. Zn2 plus again is plus 2, is the oxidation number is related to the charge, and Cu is 0 just like Zn because they are simple elements. For Zn from 0 to plus 2, the number of oxidation is increasing, so I have an oxidation. As for Cu2 plus to Cu, the number of oxidation is decreasing from plus 2 to 0, so the number of oxidation is decreasing. I have a reduction. So since I have oxidation and reduction, I can say that it's a redox reaction. Identify the reducing agent in this reaction. The reducing agent is the one which is going through an oxidation. So which one is going through an oxidation is Zn going to Zn2 plus. So it's Zn in this case. Deduce that the Zn strip is the anode of this galvanic cell. Zn is the anode because it is going through an oxidation, it is losing electrons, that's why it will be the anode. Choose among the proposed representations given below the written cell representation of this galvanic cell. Cu, Cu2 plus, no, because since Zn is the anode, it should be placed on the left side, and I should start by Zn and not Zn2 plus. So the first one we should reject, the third one you should reject, is the answer B, which is the right one, Zn, Zn2 plus, so bridge Cu2 plus Cu. The blue color of copper 2 sulfate solution Cu2 plus SO4 2 minus is due to the presence of copper 2 ion Cu2 plus. The intensity of the blue color depends on the quantity of copper 2 ion Cu2 plus in this solution. Explain why the intensity of the blue color of copper 2 sulfate solution decreases with time when the cell is set to function. So, when the cell is functioning, actually, we have Cu2 plus being transformed to Cu. How is it transformed? Due to a reduction. So Cu2 plus is being transformed to Cu. The ions Cu2 plus are decreasing in the solution. So once we have a decrease in the number of ions Cu2 plus, you will have a decrease in the color of the solution. Two galvanic cells Zn Ag and Zn Cu are constructed at standard condition. For Zn Ag galvanic cell, the anode is the zinc strip and the voltage of the cell is 1.56. For Zn Cu galvanic cell, the anode is Zn strip and the voltage of the cell is 1.1. The greater the difference between the tendencies of the metals to lose electrons, the greater is the voltage of the galvanic cell. Specify based on the preceding information which of the two axes, A or B, shows the correct order of increasing tendency of the metals to lose electrons. So, in this case, we know that Zn in the cell, Zn Ag or Zn Cu, it is Zn which is the anode. So its tendency to lose electrons is higher than Ag and Cu. But we have to check the voltage. 1.56, it means that Ag and Zn are quite separate and quite apart from each other because the voltage 1.56 is greater than 1.1. That's why I need to choose the representation B and not the representation A, because Zn and Ag are quite apart from each other regarding the voltage 1.56, which is greater. So the greater the difference, the greater the voltage, and that was the case of the representation B. That's all for this exercise. Exercise number 3, second session 2015. I hope it was helpful. That's why I'm going to ask you to subscribe to my channel. You'll be notified whenever I upload new material or new videos or I solve new exercises, and I'm going to share with you my Instagram and Facebook account. You can contact me directly or you can simply leave a comment below. That's all for this time, and see you later.